my name is Braden Thorogood. I'm hosting Geoscience Weekly. This week we have a very special guest. I'm happy to introduce world-renowned German geologist Abraham Gottlob Werner. Abraham was born in 1749 and has been dubbed the father of German geology. Abraham is here today to talk about a major mineralogical discovery. Hey, Abraham. Hey. Oh. Okay.
Thanks for having me on the show, Braden.
Yeah, anytime, Abraham. It's not every day we get a geologist of your pedigree on our program, so let's get to the point. What is the mineral you're so excited to share with us this week?
Well, the mineral is called rutile. It's a form of titanium dioxide. Spanish locals have been discussing this mysterious mineral, which in Spanish roughly translates to small steel pieces. I went to analyze samples from a small municipality just outside of Madrid.
Where was that exactly?
It was in Huerdo del La Sierra.
Oh, okay.
Excuse my pronunciation.
Okay.
Of that, yeah. But yeah, I took some specimens from a metamorphic outcrop bearing some of these small steel pieces, which yielded some very interesting results.
Can you help our audience explain some of the regional geology of this mineral? By studying this region, where else in the world can we find this mineral?
Rutile is commonly found in metamorphic rocks, forming at very deep depths, and is often associated with eclogites. This accessory mineral is found in deep plutonic settings, as well as various volcanic rocks with deep sources. The ultra-high temperatures and high pressures make rutile a very volatile mineral, which, with many types of possible crystal forms, from long, slender, prismatic crystals to thin, hair-like crystals. Rutile can also be found in hydrothermal veins and often fill pore spaces found in rocks. This unique property allows the thin needle-like crystals of rutile to be incorporated into quartz and other minerals, often called rutilated quartz.
Well, Abraham, we have millions of geologists tuned in who I'm sure are very curious what exactly this means for the geological community. Is rutile going to become a significant titanium resource?
What a great question, actually. Titanium is a very abundant worldwide material. The Earth's crust is approximately 0.6% titanium, making titanium present in the majority of the igneous rocks worldwide. Known rutile reserves are about 48 million tons worldwide. Rutile is also the second most abundant mineral ore in the world behind limonite. It is mined in various locations around the world, such as Sierra Leone, South Africa, Canada, China, and India. Rutile has titanium placer deposits that are ideal for mining titanium in Australia, the United States, and South Africa. Sorry.
So we know that rutile has high amounts of titanium in it. I believe you said second highest amount of titanium behind ilmenite?
Yeah, that's correct.
Does this mean anything to the geological community?
As far as uses in the geologic community, there are many applications. I don't want to bore you guys with those ones, though. So let's talk about the fun stuff. The industrial applications seem to have an ever-increasing amount of uses. These uses vary quite a lot, about 95% of it being refined into titanium dioxide powder, an intense white permanent pigment used in paints and plastics. It can also be used for high optic scopes and cameras due to its very high refractive index and polarized properties.
Oh, cool.
The aircraft applications as well, too. Specifically the Lockheed A-12 and its development, which led into the SR-71 Blackbird. These were two of the very first aircrafts designed with titanium frames, paving the way for much wider use in modern military and commercial aircraft.
Oh, wow.
Yeah. It is widely used as an electrode for welding worldwide. Rutile also has light-absorbing properties, which make it a crucial component of sunscreen.
Wow, sun's pretty scary. You don't want to get burnt. Rutile is an incredible discovery. Thank you so much for coming on Geoscience Weekly. I'm sure our viewers love listening about rutile, and good luck with your studies.
Thanks again, Brady.
No problem. See you later.
See you.